Good morning, students. Now we will be continuing with differentiation. In the last lecture, we have done differentiation of composite functions. Now we are going to proceed further and we are going to do differentiation of implicit function. Differentiation of implicit functions. Now firstly let me tell you what do you mean by an implicit function. Till now, whatever the types of functions that you have seen, general type of the functions y is equals to f of x. Here, one variable was expressed directly in terms of another variable. For example, y is equals to x square plus sine x. It is a function. Or y is equals to x square minus 5x plus 6. Or you can take y is equals to e raised to x. Here, you can also say that the independent variable is directly expressed in terms of dependent variable. These types of functions, whatever we have studied till now, these are known as explicit functions. Now there may be some kind of functions of the type y is equals to sine of x plus y, or y is equals to e raised to x plus y, or y is equals to e raised to y square x plus y in bracket square. This type of functions where one of the variables is not directly expressed in terms of another variable. These types of functions are called as implicit functions. So the definition of implicit function is a function where one variable is not directly expressed in terms of another variable. It's a very simple definition. These types of functions are known as implicit functions. Now remember, the explicit functions in general they are denoted by y is equals to f of x, while the implicit functions in general, if it consists of two variables, it is denoted by f of xy is equals to 0. This is the way how we write an implicit function in general terms. F of xy is equals to 0. Now examples: xy plus sine y is equals to 0, or y is equals to e raised to x plus y. We can also take y is equals to cos of x square plus 2x plus y, like that. One function is not directly expressed, so it is a mixture type. How to differentiate these implicit functions? Differentiation of implicit function is done by the chain rule differentiation. You know what is the chain rule differentiation for an implicit for a function? So here we are going to apply the previous method of composite function that we have considered. And remember, in the case of the function of the type f of xy is equals to 0, which we call it as the implicit function. As in the case of explicit function, x will be treated as the independent variable and y will be treated as the dependent variable. Here also, in case of implicit function of the type f of x comma y is equals to 0, x will be treated as an independent variable and y will be treated as a dependent variable, and we are going to differentiate it with respect to the independent variable x unless and until stated otherwise. unless and until stated otherwise. Remember, we are going to differentiate these implicit functions with respect to the independent variable, that is x. Now, let me take a very simple example and differentiate it. Y is equals to x plus sine y. Y is equals to x plus sine y. This happens to be an implicit function because the variable y is not directly expressed in terms of the variable x, or you can also take it in a reverse way. The variable x is not directly expressed in terms of the variable y. In order to differentiate, as I have already told you, we are going to apply the chain rule differentiation, and we are going to differentiate it always with respect to x. We are going to differentiate it always with respect to x unless and until otherwise stated. This is an implicit function. First, see whether you can convert it into an explicit function. It is not at all possible. You cannot convert it into an explicit function. So, in order to differentiate this type of functions, there are some working rules which we will be following in each and every example. Those working rules dictation I will be giving you when you and I meet. I don't know when we are going to meet also. Now here, first step is differentiating on both the sides. Differentiating on both the sides with respect to x. This will be the first step. LHS as well as RHS. So this is going to give you dy by dx is equals to d by dx of x plus sine y. So this will be dy by dx will be equal to derivative of x is 1. Derivative of sine y. Here y happens to be the variable. Here you are going to apply the chain rule. So this will be cos y into dy by dx. After you differentiate it, see that you collect all the terms. You collect all the terms which are containing dy by dx. That is nothing but the differential operator to the LHS. Rest all terms you transfer it to the RHS. So this will be dy by dx minus cos y into dy by dx is equals to 1. Here what is common? Dy by dx is equals to 1. This implies we will be writing only dy by dx. So dy by dx will be equal to 1 divided by 1 minus cos y. So this is how you differentiate an implicit function. So dy by dx will be equal to what? 1 divided by 1 minus cos y. So just say, given an implicit function of this type, f of xy is equals to 0 in general. So here y is equals to x plus sine y. First step is, this is step number 1. You need to apply differential operator, that is d by dx, on both these sides. So that will give you dy by dx is equals to d by dx of x plus sine y. Then you go on differentiating. After you differentiate, keep in mind that y happens to be a variable. Many of the students just write it as cos y and keep it. That will be wrong. If there is a term y, you have to always write it dy by dx. Collect the terms containing in the step 2. Collect the terms containing dy by dx to one side. Rest all terms, whatever are there, that you transfer to the other side. And then this happens to be the final step. Dy by dx is equals to 1 divided by the answer. Whatever answer that you get. This is how you will be solving it. We shall take one more example. So let me consider xy is equals to x into y is equals to xy plus y square, it's from textbook, is equals to tan x plus y. Tan x plus y, or you can also take it as sin x plus y. Here, as far as possible, try to see whether you can convert it into an explicit function. It is not at all possible. So here what we will be doing is, first step we are going to apply differentiating on both these sides with respect to x. What do we get? D by dx of xy plus y square is equals to d by dx of sin x plus y. So this will be d by dx of xy plus d by dx of y square is equals to d by dx of sin x plus dy by dx. Here which rule you are going to apply? Product rule along with chain rule. So first function keep it as it is into derivative of the second function plus second function keep it as it is into derivative of the first function plus outer function is x square, so it will be 2y into dy by dx into d by dx of y, which is the inner function y. Derivative of sin x is cos x plus dy by dx. Now this is 1. Collect the terms containing dy by dx to one side, rest all transfer it to the other side. So first term here is x into dy by dx plus this is the term which we are going to transfer it to the RHS. So this term is 2y into dy by dx, and one more term is there on the RHS which we will be transferring it to the LHS, minus dy by dx is equals to cos x. This term we are transferring here minus 1. So the final answer is dy by dx is equals to cos x minus y divided by here I am taking one step, x plus 2y minus 1, x plus 2y minus 1. This is how to differentiate. So this is my step number 1 here. Then here I have corrected. So this is your step number 2, and this is the final step that we have done. Remember here we have applied the product rule differentiation. Here we have applied the product rule differentiation. So here we are getting 2 terms, and here we are applying the chain rule differentiation. Here chain rule. This is how you are going to solve the example. So the final result that you are getting is dy by dx is equals to cos x minus y divided by x plus 2y minus 1. So in the next classes we shall continue with more problems based on this. Thank you.